What if I told you every time you solve for x, y, h, or t, you are secretly unlocking the same math that engineers, pilots, and game designers use daily? Today, we're not just solving equations, we are rearranging the rules themselves. Welcome back to Algebra 101. I'm Special K, and today we are diving into literal equations, where letters talk to letters. Think of it like a math Lego blocks. The same pieces can build anything, a physics formula, a geometry rule, or even a computer code. We learn how to isolate any variable you want step by step, like solving for heights in A equals to half of B times H, or finding R in Ohm's law, V equals to R times I. By the end, you'll see that rearranging equations isn't about memorizing. It's about mastering control. You decide which variable takes the spotlight. Grab your notebook, it's time to flip formulas, solve smart, and think like a pro problem solver. Let's go. Hello everybody, hope you're doing well. Without further ado, let's start the next module, which is about the literal equations and rearranging formulas. So again, at this point, instead of just working with solely number, if you remember from normal equations that, for instance, we do have x is equals 3 plus 7. So it is simple. The only thing that you have to do, solve the whole equation for x, and after that, try to find the x value. But at this point, we are only going to work with the numbers and the letters. It means that at this point, we are going to find the answer for specific variables based on the letters, and our final answer again going to contain letter. So I will talk about it to not get confused. So let's talk about first of all about the objectives that we do have for this section. So we are going to solve for a target variable, as I just told you. At this point we do have x, y, z, or any other kind of variable, and in one section or one side of equation, and another side of equation is not going to be not just numbers, which we know it from the normal equation. At this point is going to be numbers and the letters, which we don't know about. But the question is, solve this equation based on this specific variable. After that, we are going to rearrange the geometry and physics formulas. So at this point, I thought it would be better to work only on examples. And I have to say only, mostly on examples, in order to completely understand that how actually we can use it in different kind of subjects. After that, we are going to convert the linear forms to slope, interact, and standard. So this is going to be another module. Actually, we are going to talk about it in the future of Algebra 101, but at this point, I'm going to mention a little bit. For some of you, maybe has a little bit of information that what is going on. You can be understandable. But again, don't worry. You don't have to completely know what is happening. The only thing that we are going to focus is how we can rearrange our formula in order to reach to the thing that we want. And at the end, we are going to check the result by substitution and units. If you remember from the equations, I told you that if you want to make sure that your answer is going to be fine and right at the end, whatever found as a number, again, for equation, we were looking for only numbers. Whatever we found as numbers, we are going to substitute within our variable to see and make sure the right and left side of equations are going to be the same itself. So first of all, let's start with a definition. What are literal equations? The literal equations uses letters to represent numbers or formulas. It means that at this point, instead of just isolating the target variable and as one side, and after that find numbers on another side, we are going to use the inverse operations just like the normal equation itself and keep the equation balanced and use the step-by-step approach in order to find that value. So if you remember a normal equation, after doing all of these things, like the one that we do have on this scale, I do have x is equals, for example, 7 plus 3. So it is simple, nothing wrong with that. I do have one specific number for myself. But at this kind of equation that we are going to talk about in 2 slides, you will going to see that actually we are going to have one letter on one side and other kind of letters and numbers on another side. So before just talking about that, let's talk about the normal equations that we have before. So as you can see over here, I do have different kind of steps that I have to consider. Actually, we were talking about it. For some of you that still cannot handle this kind of equations, it would be better to just try to rewatch the previous videos that I had about the inequations and inequalities. I explained everything using examples and using different videos and completely explain to you what are the recipe, especially about the 6-step recipe that we have in order to handle all of the equation. And at this point, I'm going to show you just a few examples how we can handle it, and we are going to apply it for our literal equation. So at this point, I do have 3x plus 5 is equals to 8. As you know, I have to move all of the numbers into one side and keep all of the variable on another side. So I have to subtract both sides from 5. You know that this is the inverse operation, and I do have 3x is equals to 3, and then I know what should I do, which is going to lead me to the next step. The next step is multiply or divide to peel the coefficients. It means that at this point the answer is x, so I'm not looking for 3x. Somehow I have to get rid of it, right? How I can do that? By the inverse operation. Since at this point I do have 3 multiplied by x, I can just do the division. Divided by 3, and after that I do have x is equals to 1. Another thing that I have, if you guys remember, especially from our alike and unlike terms video, we were talking about the fact that at the end we are looking for a way in order to simplify our equation as much as possible. Like this question, as you can see, I do have x plus 5x is equals to 12. So either we can do the factoring, actually I haven't still talk about it in the future, I will talk about that one, or I can just add them up. X plus 5x obviously is going to be 6x, so my 6x is going to 12, and at the end I know how to handle that. Another thing that I told you in an equation was that fractions are going to be problematic, so it would be better to at the beginning get rid of them, and also make sure that you are going to consider the domain. What was the domain? If I do have a question like this, that 1 over x plus 3 is going to be part of it, just before get rid of this fraction, obviously we know that we have to multiply both sides by x plus 3, I should know for a fact that x cannot be negative 3. I don't care, and at the end I found the answer, and maybe one of the answers is negative 3. The negative 3 is not going to be the answer. Maybe some of you would ask why that's the case. Use your calculator, write down 1 over 0. You will see that you will get an error. So 1 over 0 is one of the kind of fraction that is undefined. So imagine that I do have 1 over x plus 3, and the number that I found as x is equals negative 3, and 1 over 0 is going to be disaster, right? So make sure to define your domain before doing all of that. So at this point, I do have x over 3 plus 2 is equals to 7. So how can I get rid of fraction? By multiply both sides by the common denominator, and at most of the point, least common denominator. So what was the least common denominator? That was a number that is going to be divided by all of the denominators that you have in your equation itself. So at this point, the only fraction that I have, or only denominator that I have, is 3, right? So by multiplying both sides by 3, I can get rid of it as that x over 3, or make it as x. Be careful when we are talking about the multiplication, division, or any other kind of operation from both sides. I have to keep the balance. Whatever that I'm doing with one side, I have to do it with another side. Why? Because at the end, we are not going to change anything. The only thing that we are doing right now is try to simplify everything for ourselves. Rather than that, if you forget to do that part for one side, you're probably going to find a number, but at the end, that number is not going to be right. How I know that? Because if you put that number using the substitution method and put it in your first equation, your left and right side of the equation are not going to be equal. So be careful about that. X over 3 plus 2 is equals to 7. Multiply both sides by 3. You know that x over 3 times 3 is going to be just x itself. This guy times 3 is going to be 6. This guy times 3 is going to be 21, and I know how to handle that. Another thing that I told you, and actually I talked about it, about different kind of laws, the distributive law and other kind of related thing, was that as soon as you see a fraction, as soon as you see a parentheses, try to make sure that you don't have it anymore. Why? Because parentheses is just another form of factorization, but I don't like that. Why? Because whenever they are there, actually I'm going to lose something. So it would be better to simplify it, get rid of parentheses by the way that we know it about the distributive rule, and after that try to simplify everything in order to find our equation. For instance, at this point I do have 3 times x plus 2 is equals to 15, right? So as you can see over here, I do have 3 times x plus 2 is equals to 15. So if I still do have the fraction, it's not going to be helpful that much. So I'm going to get rid of the fraction, by multiply the 3 by both x and 2 in it. 3x plus 6 is equals to 15, and I can find my x. Maybe some of you would say that, okay, at this point it seems that I somehow get rid of fraction by another way. And what is that? Divide both sides by 3, and I would say that that is completely right. At this point, you're getting rid of fraction, and the only thing that would still beside your fraction is 1. As we know, 1 multiplied by each term or each number is just itself. So at this point, you can easily divide 15 or both sides by 3, and you still can find the right answer itself. So let's talk about some examples, and let's talk about what does actually mean when we are talking about literal equation. So as I just told you, this kind of equation means that instead of just having only numbers in one side and only variables in another side, we do have variables in both sides, or we do have letters in both sides. But we still have some hints, because the question specifically will mention that you have to solve the equation based on what. The one thing that we have to know, and actually is somehow hidden in all of the question that we have related to equations, for example, x plus 2 is equals 3x plus 12. So this is something that you know, but actually is there, and it's some kind of absolute. So what is that question? The question is find a value or solve the equation based on x. In equation, we didn't have that much of a problem, because the only variable that we have was x, and all of the other numbers could move another side, so everything was simple. You only have x, and after that other parts. But at this point, I do have letters, and I have to somehow manage everything to make sure that I'm not going to mix and match one letter with another one, and also based on the fact that numbers are going to be there as well. For instance, at this point, let's look at a very, very simple formula. This geometry example is about how you can find the area of a triangle, obviously. So A is equals to half times B times H. By the way, whenever you see that something like this question and there's nothing between them, for sure, you know that it's about the multiplication. So the question specifically asks to solve this equation for H. It means that you have to move all of your variables into one side. I don't care if you have numbers, letter, whatever, and move and only keep your letter or keep your variable or the one that we are looking for in one side. So if I would like to find it for H, obviously I do have two problematic parts. The first part is 1 over 2, which is a fraction, and another one is B is working as the coefficient. Again, it's not going to be constant coefficient, but still is considered as a coefficient. So how I can get rid of that? The first thing that we saw about the equation was somehow I have to get rid of fraction. How I can do that? Multiply both sides by the common denominator. Since the only fraction that I have is 1 over 2, I can multiply both sides by 2. So at this point, I do have 2 times A, 2 times half of B times H. Since I do have the multiplication, the only thing that I have to do, I multiply 2 by half itself. It's automatically going to be multiplied by the rest. So I do have 2A is equals BH. So that was the first step. After that, I know there's a coefficient there that I don't like. So somehow I have to get rid of it. What can I do? Exactly, inverse operation. So I had multiplication between, the only thing that I have to do, divide both sides by the thing that I don't want, and at this point my H is going to be simple, it is going to be by itself or single, and after that I do have 2A over B. So right now I found my answer. It means that I solve A is equals half of BH for H itself. Let's see another example. I do have 12 times BH for H. Again, I'm trying to solve that one. So as you can see over here, we don't have any fraction, but we do have two coefficients. So we can get rid of both of them at the same time, because 12b can be considered as big B, or we can consider it as a big some kind of coefficient, and divide both sides by 12b. Both sides by 12b, and at this point this 12b is going to cancel out this one, and A over 12b is going to be my answer itself. So let's see another example, and at this example I do have P is equals 2L plus 2W itself, and the question specifically asks to find it for W. So at this point, rather than just the numbers and multiplication, we also do have addition. So it means that somehow I have to make sure that my W, or at least 2W, is going to be alone. How I can make sure about that? This 2L seems some kind of extra on the right side. So the only way that I can get rid of that is 2L, subtract the 2L by both sides. So for the first step, I do have something like this. Am I done? No. Why? Because the question specifically asked to solve it for W. It didn't ask to solve it for 2W. So this coefficient should also be vanished. How can I get rid of that? Again, inverse operation. Inverse operation. I have to make sure the whole thing, which is P minus 2L, is going to be divided by 2. It means that P is going to be divided by 2, negative 2L is going to be divided by 2. And at the end, I do have this one as my result. Let's see another question, which is a very, very famous formula in electrical field. So V is equals R times I, we know it as Ohm's law, and we are going to solve this equation for r and for I itself. So how can I do that? Again, remember, if we are going to solve it for r, means that r is going to be alone by itself and the rest would be on the right side. So v is equals r times I. How can I make r alone? Exactly, I is extra. So I can divide both sides by I and I'm good. So r is going to be v divided by I itself. So if I want to solve it for I, what should I do? The same thing. At this point, I have to make I alone. So divide both sides by r and I'm good. And as you can see, this is the final answer itself. After that, let's solve another one. D is equals to RT, and I'm going to solve it for T and R. If I want to solve it for R, for example, for T, for the first one, what should I do? I have to get rid of R, divided by R, divided by R. So D divided by R is going to be T, as simple as that. If I'm going to solve it for R, again, I have to get rid of whatever is extra rather than the R itself. What is extra over here? At this formula, D is equals to RT. If I want to solve it for T, for R, T is extra, so divided by T, and at the end, I do have this answer itself. Let's have another equation. At this point, this is the kind of very important equation. We are going to talk about it later in detail about the Algebra 101. Y is equals mx plus b is the linear equation, and it's equation related to a line. And it means that, as you can see on the bottom side of the slide, there is a line, and actually that one has a specific equation for itself. Using that equation, if I put any number in x, to be honest, m and b are going to be some kind of decided, and those are numbers. So at this point, we do have them as letters, but most of the time they are known. So if you put any number in x, you can find a y, doesn't matter how big or how small is that. So y is equals mx plus b, I'm going to solve it for y itself. It means that I have to find a way in order to make x by itself. So the very first way is that obviously I have to get rid of b. How can I do that? Subtract both sides by b. So I do have y minus b is equals to what? Is equals to mx. And another problem that we do have about mx is that actually I'm looking for x, not mx itself. So I have to divide both sides by m. So make sure that x is going to be itself, y subtracted by b divided by m. Be very, very careful. Because I saw a couple of students that instead of just dividing the m at this point or any other kind of coefficient, instead of just dividing all of the parts on another side by that one, they're going to only apply it for one. So at the end, again, you will find a number. So it doesn't matter, you will find an answer. But your answer is not going to be right. If you put it and using the substitution method, you're not going to find anything that could answer your work. So please double check and be careful about your work and make sure that whatever you're doing with one side, you have to do it with another side itself. After that, we do have a little bit more challenging one. So at this point, I do have ax plus by is equals to c. So as you can see at this point, there is no number in it. So maybe at the first glance, you will see that, oh my God, what should I do? You're going to panic because, yeah, if I were you and if I didn't know anything about the algebra equation, I could do the same thing. But at this point, I know, because the question is not to find a number for y. The question specifically asks based on the thing or based on the equation that you have, find something and solve it based on y. It means that the only thing that you have to do is just make y alone by itself without any coefficient, and after that move any other part to another side. So let's look at this one. I do have ax plus by is equals to c, and I'm trying to solve it for y. How can I do that? Obviously, first of all, I have to make by or y alone. So by is going to be c subtracted by 1 ax. Y subtract because I know ax is extra. So I can just kind of subtract it from both sides. At the end, I do have something like this. So I know the question specifically asks for y itself. So by is not my answer. First of all, I have to divide both sides by b. And at the end, this is going to be my answer itself. So as I just told you, y is equals to this part plus b, or y is equals to mx plus b. M at this point is negative a over b, and b, which is a constant, is c over b. Again, don't get some kind of confused and try not to get panicked. This is not something scary. Again, we are going to talk about it in detail in future part for sure. So this is just a very, very common equation that probably you saw in high school related to your linear algebra. So let's move to the next one, and it's some kind of about strategy pattern. As I just told you, try to target variables appears multiple times. How you can target them? It means that when you have 5x and 2x, make sure that both of them are going to be in the same side. Why? Because using the like terms, we can simplify them. And if you have lots of fractions, the very first way that you have to do, multiply both sides by the least common denominator or common denominator. At this point, we do have 5 and 3 as our denominator, and the least common denominator or denominator is going to be 15. Multiply both sides by 15 and you can find your x itself. So if you have radicals or exponents, the only thing that you have to do is, again, use the inverse. The inverse of radical is using the power. So it means that when radical of x or root of 2 of x is 5, the only thing that you have to do is multiply both sides by the power of 2. So what you got? You have x is equals 25 itself. As simple as that. Another thing that you have to be very careful is the power of 2 itself, because you'll see so many questions that at the end you're looking for an answer, and most of the time the only answer you're looking for is just one number. But at some point it's not only one number, it could be 2 or it could be more. So at this point I do have y2 is equals to 16. So the very first thing that you would think is that, okay, y is equals to 4, right? I mean, it's not wrong, but it's not completely right. Why? Because if you guys remember, negative numbers are considered as part of the numbers, right? So 4 times 4 is 16, but what about negative 4 times negative 4? This part also can be considered as 16, right? Because negative times negative is positive, and 4 times 4 is 16, so please be careful at this point. Again, in the future, we are going to talk a lot about this kind of equation again. After that, this is the point for your try. I mean that you can pause the video, and after that, based on the question that I put it for you, try to find a solution for them and see that actually the answer we got is right or not. So comment, well, in the comment section comment for me to make sure that you completely understand it. And if you have any problem, please ask me, and after that I can explain it to you. If you don't have a problem, I can make a separate one for you as well. After that part, let's talk a little bit about some common mistakes. Again, I told you a couple of them. So make sure when you're doing some kind of division, or when you're using parentheses, use it right, because at this point, this part, 2x plus 6 divided by 2 is equals x plus 3, is completely different from this one. Why? Because at this point, first of all, based on the PEMDAS, or order of operation, we have to divide these two, and after that use it 2x. But at this point, I have to divide both of them by 2 itself. So these two parts are different. Be careful. After that, try to make sure to know about the negative itself, because at some point, you do have, for instance, x subtracted by 5 is equals to 10, and sometimes you forget that it is negative, so you have to use the positive sign in order to get rid of 5, so please be careful. And also make sure about the one thing that I told you about, x to the power 2 is equals to 16, so x also can be positive and negative itself. And after that, at the end, make sure that when you're solving for one variable, you cannot simplify it. It means that as soon as I give you something like this, 2x plus 1, we know that those terms are not like terms, so you cannot simplify them or you cannot combine them. Make sure about that. After this part, we do have a very, very important section, and we do have the final step of all of the equations. The equations that I was just talking about, especially about the number-wise, we do have the method that we call as a substitution method. It means that at the end, when you find any number for your variable, you have to put it into the first equation to make sure the left side and right side of equation is going to be right. For instance, I do have v is equals to ri, and I solve this equation for what? I solve this equation for r, and I do have r is equals to v over I. So what would happen if I put this one again over here? So I do have I times V over I. So this I is going to cancel out this one, and one side of the equation is V, another side is V, so I know for a fact that my equation is going to be right itself. So we also do have another part about the units itself, the units check. So it's not going to be that kind of important, but I thought it would be better to have this part over here. So right now we reached the end section of the module 5, which was about the literal equations. Again, remember that not all equations are going to give you one solid number. Some of them are going to give you more than one number, and some of them are going to give you numbers and letters. So you have to be prepared for both of them. Again, if you like it, please like, comment, share, and that would be so helpful for me. This is Mahmoud Kiasari. Have yourself a great day, night, whatever. See you around.